Hello, and thank you for taking the time to watch this video. My name is Aidan, and for this video, I will be explaining Forecasting Indonesia's Marine Commodity Exports, a deep learning and clustering approach, a study conducted by myself and my two colleagues, Ray Steven Letianto and Michael Simay Latarima. Before getting into the study, I will start by explaining the role of the marine trade in supporting Indonesia's economy. Indonesia's vast marine resources plays a significant role in the global seafood trade and serves as one of the many backbones that supports the country's economy. Now, the importance of the forecasting itself, which is conducted in the study, is that accurate forecasting is crucial for decision making in industry, policy making, negotiations, and supply chain optimization. And therefore, the goal of this study is to combine clustering and deep learning approaches, such as using the GRU model to forecast export data and analyze trends to gather insights for better decision making. Now, let me explain the methodology of the study, which starts by collecting and pre-processing the data. Marine commodity export data, sourced from the Ministry of Marine Affairs and Fisheries from Indonesia, contains values from January 18 to October 2024 across 40 plus species and nearly 200 destination countries. The data is pre-processed, where it undergoes missing value handling, min-max scaling, and interquartile outlier detection. The table below is an example of the row of data taken from the dataset. So from the table below, it shows a data record from a transaction that happened in the year 2018 on the month of May, with the commodity being exported as abalone to the country of China, with a value of 132.5 USD and a volume of 26.5 kilograms. The next step in the methodology is known as data clustering. Data clustering using the agglomerative clustering approach was implemented to group export data based on fish types and export values, aiding the study in predicting complex patterns. The chosen cluster approach resulted in a number of clusters n equals 3 and is divided into clusters 0, 1, and 2, respectively. Cluster 0, with a size of 4,674, is characterized by relatively low export values, representing a majority of the observations. Cluster 1, with a size of 656, displays moderate export values intermediate between Cluster 0 and Cluster 2. Cluster 2, with a size of 82, comprises of relatively high export values. The pie chart below visualizes the clusters, each divided by three colors with their respective value sizes. Next, we will be discussing the structure of the GRU model, which will be explained by Michael.
Thank you to my friend for the explanation. Here, I want to explain about Gated Recurrent Unit or GRU model. A Gated Recurrent Unit or GRU is a type of recurrent neural network or RNN designed for efficient sequential data processing. It excels at capturing long-term dependencies and mitigating the vanishing gradient problem more effectively than standard RNN. GRU reduces computational complexity by using fewer gates, while maintaining the ability to capture sequential dependencies. GRU is selected for its computational efficiency and capability to model long-term dependencies in sequential data. Unlike LSTM, which incorporates three gates, which is input, forget, and output, the GRU accelerator simplifies the gating mechanisms by using only two gates, which is the update gate and the reset gate. Therefore, we choose Gated Recurrent Unit or GRU model for our research. Thank you.
Thank you for the explanation, Michael. Now let's discuss the results of the experiment. The experimental setup involved splitting the data into 80% for training, 10% for testing, and 10% for validation over 6 years worth of marine commodity export data, spanning from 2018 to 2024. Based on the results of the experiment, the mean absolute error and root mean square error values obtained from each of the cluster models are deemed acceptable since they are lower than the standard deviation. The table below illustrates the results of each of the cluster models and their MAE, RMSA, and standard deviation values after being processed to the model. Feel free to pause the video to further observe and analyze these values. To conclude the study overall, this study successfully developed a predictive model for Indonesia's marine export using a combination of clustering and deep learning techniques, particularly the gated recurrent unit or GRU model. By applying agglomerative hierarchical clustering or AHC, the export data was categorized based on fish types and export values, which served as the foundation for time series data forecasting. This clustering enhanced approach enabled more accurate and targeted predictions by addressing the heterogeneity in the data. The experimental result revealed that the predictive performance varied across clusters, with some achieving lower mean absolute error or MAE and root mean square error or RMSE. Thank you again for watching this video. We hope the points explained in this video were clear and understandable, and that this video may contribute to other related works in the future.